Hey fellas, it's your girl next door, Alyanna, and welcome to the first episode of MuSci! In this series, we'll be using our music skills to understand scientific concepts and make them more interesting. We have to admit that sometimes learning science is tricky, especially learning physics. Don't worry, I'm going to help you. For today's episode, we'll be tackling about Newton's laws of motion. I'm pretty sure that you have encountered this topic during your high school days on your science classes. You always hear a driving car or simply taking a walk as examples, but I have a different but more interesting experiment that best explains the Newton's laws of motion. But before we proceed to the actual experiment, let's tackle first the Newton's laws of motion itself. The Newton's laws of motion describe the relationship between the motion of an object and the forces acting on it. The laws of motion are law of inertia, law of acceleration, and law of action and reaction. Now that we're about to explain each law of motion, the actual experiment will be used to further understand the concepts. For the actual experiment, the piano will be the only material needed to be utilized by the magical fingers shaped by experience. The first law of motion states that an object at rest will stay at rest and an object in motion will stay at motion at constant velocity unless acted upon by an unbalanced force. To further expand the concept, I will be showing you the actual experiment, which first I will be leaving it alone. Then, I'll press the piano keys to show how the first law of motion is applied. The explanation on the first part of the experiment is that the piano doesn't make a sound when you leave it alone or when you leave it at rest. When you press the keys, it will make a sound and the strings will start to vibrate, stating that it's already in uniform motion. It will stay in motion until acted on by another force, which is gravity. Second law of motion states that when a force acts on a massive body, it causes it to accelerate. Hence, there will be a change in velocity at a constant rate. To show how the second law of motion is applied, I'll be playing an excerpt from Sabre dance by Aram Khachaturian because of its fast tempo and the heavy sound which is caused by the large amount of force applied. The explanation on the second part of the experiment is that the more force you apply to the keys, the more acceleration the strings will have. And the more mass you apply when pressing the keys, the strings are more accelerated. It's evident in the sound produced as I apply more force in playing an instrument shown in the video. Last but not definitely the least, the third law of motion. The third law of motion states that in every action, there is an equal and opposite reaction. The third law of motion is also known as the law of interaction because it shows the cause and effect between the force applied to an object, which is the independent variable, to the motion of an object, which is the dependent variable. I'll be showing you the effects of applying too much and too little force when I play Fifth Symphony in C minor by Ludwig van Beethoven. The explanation of the third part of the experiment is that when you press the keys with a lot of force, which is the action, the sound will be bigger. Hence, the reaction will be more vibrations produced from the strings. If you apply a little force, the sound won't stay loud for long. Since we have finished tackling Newton's laws of motion with the utilization of music skills on the actual experiment, I hope that you learned from it. Thank you for watching, and again, this is your girl next door, Alyanna, and see you on the next episode. Bye!